Today we will study the estimation of sodium carbonate and sodium bicarbonate in a mixture of the two theory. The estimation of sodium carbonate and sodium bicarbonate in a mixture of the two is based on the selective use of indicators. An acid neutralizes sodium bicarbonate in one step and sodium carbonate in two steps. One sodium carbonate reacts with hydrochloric acid to form sodium bicarbonate and sodium chloride. 2 sodium bicarbonate reacts with hydrochloric acid to form sodium chloride, water, and carbon dioxide gas. 3 again. Sodium bicarbonate reacts with hydrochloric acid to produce sodium chloride, water, and carbon dioxide gas. Phenolphthalein acts as an indicator for the first reaction. But as soon as the second and third reactions start, phenolphthalein fails to act as an indicator because its color is discharged by the liberated carbon dioxide. Therefore, when the mixture is titrated against a standard acid using phenolphthalein indicator, it will indicate the completion of the first reaction. After the completion of the first reaction, then methyl orange is added and titrated with the same acid to denote the completion of the second and third reactions. The volume of acid used with phenolphthalein as an indicator corresponds to half of the sodium carbonate, while the rest of the sodium carbonate and the whole of the sodium bicarbonate are equivalent to the acid used with methyl orange as an indicator. Procedure. Take 25 milliliters of the supplied mixture in a conical flask. Add 1 to 2 drops of phenolphthalein indicator and titrate it against standard N/10 hydrochloric acid. The end point will be known by the disappearance of the pink color of the solution to become just colorless. Note the end point carefully. Then add a drop of methyl orange to the same colorless solution in the conical flask. Titrate the solution again with the same standard acid. The end point will be denoted by the change of color of the solution from yellow to pink. Note the end point again. Repeat the titration to take at least 2 to 3 concordant readings. Observation. 25 milliliters of the alkali mixture were taken for titration. 2 indicators were used, phenolphthalein and methyl orange, with standard N/10 hydrochloric acid solution. For phenolphthalein indicator, the initial burette reading was 0.0 milliliter, and the final reading was 6.4 milliliters. So, the difference or titer value is 6.4 milliliters. For methyl orange indicator, the initial burette reading was 6.4 milliliters, and the final reading was 25.4 milliliters. Hence, the difference or titer value is 19.0 milliliters. For 3 concordant readings, the average volume of acid used with phenolphthalein indicator was 6.3 milliliters, and the average volume of acid used with methyl orange indicator was 18.8 milliliters. Calculation. Volume of acid required to neutralize half of sodium carbonate in 25 milliliters of the mixture, V, is equal to 6.3 milliliters. Therefore, the volume of acid required to neutralize the whole of sodium carbonate in 25 milliliters of the mixture is equal to 2 times V is equal to 2 times 6.3 is equal to 12.6 milliliters. Volume of acid required to neutralize half of sodium carbonate and the whole of sodium bicarbonate in 25 milliliters of the mixture, V, is equal to 18.8 milliliters. Therefore, the volume of acid required to neutralize only sodium bicarbonate in 25 milliliters of the mixture is equal to V is equal to 18.8 6.3 is equal to 12.5 milliliters. For sodium carbonate, in 25 milliliters of the alkali mixture, the volume of acid required is equal to 12.6 milliliters of N/10 hydrochloric acid with correction factor 0.99. 1000 milliliter of the alkali mixture equals 12.6 multiplied by 0.99 multiplied by 1000 divided by 25 multiplied by 10 milliliter normal HCl. Therefore, 1000 milliliter of the alkali mixture equals 49.896 milliliter normal HCl. This also means 49.896 milliliter normal sodium carbonate. We know that 1000 milliliter normal sodium carbonate solution contain 53 gram of sodium carbonate. Therefore, 49.896 milliliter normal do equals 53 multiplied by 49.896 divided by 1000 gram of sodium carbonate. It equals to 0.645 gram of sodium carbonate. For sodium bicarbonate, NaHCO₃, 25 milliliter of the alkali mixture equals 12.5 milliliter normal, bracket 10 upon 25, which is equal to 0.99 HCl. Therefore, 1 milliliter of the alkali mixture equals 12.5 multiplied by 0.99 divided by 25 multiplied by 10 multiplied by 1000 milliliter normal HCl. 1000 milliliter of the alkali mixture equals 12.5 multiplied by 0.99 multiplied by 1000 divided by 25 multiplied by 10 milliliter normal HCl. It equals 49.50 milliliter normal HCl. This means 49.50 milliliter normal sodium bicarbonate. We know that 1000 milliliter normal sodium bicarbonate solution contain 84 gram of sodium bicarbonate. Therefore, 49.50 milliliter normal do equals 84 multiplied by 49.50 divided by 1000 gram of sodium bicarbonate. It equals 4.158 gram of sodium bicarbonate. Therefore, 1000 milliliter of the alkali mixture contains 2.645 gram of sodium carbonate and 4.158 gram of sodium bicarbonate.